All the yellow and blues making around?
Isn't there one more row for the blue?
At this point, maybe I should just put them up front at this point, and I'll let people come on up if you want it.
So, thank you.
Thank you. So they're up here. Feel free to run up if you want them, or after class, either way, whatever. Yeah, the other yellow and blues are up there. All right. So, yeah, so we're doing the properties of logging. So, again, I just want to be clear. This week, this Friday, is the last day to drop. So if you drop this week any of your classes, you'll get a W on your transcript, withdrawal, but it won't affect your GPA. No effect on your GPA. But starting next week, you're in for a letter grade for sure. A, B, C, D, or F that will be on your transcript for the rest of your days on the planet. So make sure you want that.
Is it that bad? Yeah.
It's that serious.
It sounds like it starts for win.
What's that?
Like you win.
You win?
Yeah, because you don't take it out. You win.
Oh, W for win. Okay. Okay. We'll leave it at that. So anyway, so this week, just want to let you know the rules of the game. You know, you want to play the college game, right? It's really important to get advice with your classes and all that. All right, we better move on. So I'm glad to help if there's anything I can give advice on. Okay, so this week. So let's move ahead with the logarithm stuff. So log base 6 of that. So log, so we have those three properties. That's right. It's all coming. I'm forgetting what we were even doing. Those three properties. Remember the three log properties? Number one, the log base b of x times y is log base b of x plus log base b of y. Remember, multiplying becomes adding, right? And log base b of x divided by y. Let me just change the color there. So when you divide, that becomes subtraction. X over y becomes log base b of x minus log base b of y. And then the third property is a little different. It's the power comes in the front. So log base b of x to a power, the power comes down to the front. Okay, so those were the three properties. Remember those? So this whole section is really about just using those three properties again and again and again. So this one, they're giving me log base 6 of 1296x, and they want me to, I kind of wrote over the words up there, but it says write it as a sum or difference of logarithms, plural. In other words, make this one log into 2. One log into 2. So how do I make this one log into 2? Well, first off, the base doesn't change. Are we good with that? See how the b, that never changes. You never mess with the base on these properties. It always just stays as it is, no change. So that'll stay the same. What's going on in the middle of the 1296 and the x? What's in the middle there? Yeah, multiply, huh? So multiplying becomes adding, doesn't it? So log base 6 of 1296 plus log base 6 of x. That's all they want. Well, no, this probably I can probably do something with that. But so far so good. Pretty good with the first step. Remember, harder job for one person, easier for two. It's always that way, right? Harder job, it's times. Multiplying is a higher operation than adding, which is lower, simple. First thing you learned when you were a kid in math, adding, right? So harder job for two, easier job, no. Harder job for one person, easier job for two people, 2 logs. It's the concept, right? Okay, now this, what about this part right here? I would just use my calculator. Remember how to make it into 2 logs? 1296 over 6. Remember, you can make 1 log into 2. The high goes high. The higher one goes to the top. The low one down one goes to the bottom. Hit the buttons on your calculator. It was like 3 or something, or 4? Is it 4? 4. Isn't that 4? I'm kind of guessing. Is it 4? It is 4, right? Yeah. Plus log base 6 of x. That good? See, this one we can simplify because it's all just numbers. Whereas that one with the x just has to stay that way. And there we go. Okay? Questions?
Can you plug it in to be sure?
You're always doubting me, man.
I just want to be sure when I plug it in.
No, I'm sure of that one. That one's good. I'm sure of that one. All right. Log base 6 of z to the 9th. Okay. So what does that power do on that one? goes down to the front. That's the best quality. So that 9 comes to the front. Like that. And that's it. That's all they want me to do. That's the third property, right? The only property that just stays one log instead of one log to two, one log to two. The third one is just one log to one log. Power comes to the front. Remember how logs are always lowering everything by a level on the PEMDAS? If you get rid of the P, we don't have any parentheses here. Remember I talked about that, right? The 3 levels, adding, subtracting, multiplying, dividing, and powers. And see how it took powers down to just multiplying, powers drop down to multiplying? That's what logs do. They lower everybody by a level of on the order of operations, because logs are reverse powers. So it undid that power and made it multiplying. Better get moving. And I remember there's some tricky ones at the end. I better go fast. All right. No stories today. I got to get through this. All right. I'm saying that for my own benefit, for my self-control. No stories. Natural log of x to the 13th times the root of 3 minus x. So same thing. They want me to see how they say make it sum or difference, adding or subtracting of a couple logs. So can you do that one? Let me give you a second. Let's go ahead and do that. Break it into natural log is the same as any of the other logs. It's just all the same rules. You know, natural log just means base e. You don't have to write the e or anything. Just do the same thing as you would with any log. Break it into 2. Break it into 2. So it's going to become adding, right? So far, so good, right? Because this is times here. So x to the 13th. That 13 is not in the hook. I didn't write that very clearly. Let me make sure that that 13's on the x, and then times like that. Good so far. So multiplying, harder for 1 log, easier for 2. Okay, and then remember power comes down to the front. So we're going to do a couple of the properties on this one. So that power comes down to the front, like that. Okay, and now there's something that you have to do with that root. Let me show you guys. Remember what we learned about fractional powers? Let me just take something like W or whatever. Do you know like W to the 2/3 power? Do you remember from your algebra days? I can't remember if we've done it in here or not. Anyway, remember how fractional powers can change into roots? Remember that the denominator can swing around like that? Remember that kind of thing? No, some do, some don't. Yeah, it can do that. Didn't I do the Scooby-Doo thing and talk about that?
That's
No.
you should share that story right now.
It's not really a story. I watched a lot of cartoons when I was a kid. Too much Scooby-Dooby-Doo. But I always remember in the little introduction, he would fall into a trap. So, whatever. Probably just helps me and probably nobody else. But I look at that little denominator, and he swings around into the trap. Just reminds me of Scooby-Dooby-Doo running and falling into the trap. So there we go, if that helps you, whatever. Bottom of a fraction. Fraction power means a root. You aware of that? That they're gonna make us use that a lot. So fraction power means a root. Specifically, the denominator swings into the hook, like that. You can change back and forth at any time. If somebody gives you like the 7th root of a to the 5th or whatever, you could swing the 7 back around, and it's a to the 5/7. So denominator, hook, same thing, either way. Sometimes this is easier to work with. Sometimes that's easier to work with. Depends what you're doing at the moment. There are just 2 languages for saying the same thing. Fraction powers or roots. Same thing. The denominator number is the hook number. It's the number in the hook. Same thing, 2 different languages. Okay, now why do I care about that? Well, on this problem, notice they're giving me a root. Okay, but it's a little more tricky than that. Let me help. What if you had a to the half power?
Isn't that?
Yeah, so again, we could swing Scooby-Doo around into the thing. The top number, a to the 1, just stays a to the 1. That doesn't change, but the denominator swings around into the hook, right? Like that? We good? Now, what can you do with that from there? What can we do? Yeah, that's just square root of a, because the 2 is understood and the 1 is understood. Huh? You aware of that? Right? If we don't show any power, it means 1. And if you don't put anything in the hook, it means 2, doesn't it? It's about the only understood 2 I know of in math. Exactly. So whenever you see a root, just like a plain root, nothing showing, nothing in the hook, no power showing, on anything, not just A, could be on whatever, like here, you should think, oh, that's a 2 in the hook, and all this is to the 1 power, so swing it around, that's 3 minus x to the half power. Right. A root is a half power. You tracking with me on that? A root is a half power because the 1 and the 2 are understood. Okay, so what? Well, then the power can come to the front. Remember how logs always let powers come to the front? So a root is a half power, and for logs, powers come to the front. So it'll be a half ln 3 minus x. And now we're done. We did all the simplifying we could do. So whenever you got a root in a log, make that a half power and then bring that half to the front. Good? Questions on that? Remember all that root stuff from your algebra days? Okay, so we have log base 3 of x to the 14th over x minus 5. Don't the x greater than 5, don't worry about that. I'll explain it later. You don't do anything with it. So now they want me to oh, same thing, huh? Yeah, I thought it was different. Yeah, make it into 2 logs. So go ahead, make that into 2 logs. So this time they're divided. So what is that going to become with 2 logs? Subtraction, right? This is property number 2. Dividing becomes subtraction. Right? Dividing and subtraction both makes things smaller, don't they? So they go together. Like adding and multiplying both make things bigger, and they go together. The base doesn't change. You do, by the way, you do need parentheses around that x minus 5. Math Excel won't give you credit, and technically it's right. Why? Why do I have to? What if I just wrote like that? Why isn't that the same thing? Why isn't that good enough without the parentheses? Cyrus?
It's like you're subtracting 5 from 1.
Yeah, the 5's not in the toaster that way. Yeah, you're totally right, Cyrus. It's like the 5 is just out here totally separate. Even they think, well, I wrote it real close. Well, real close, doesn't officially work, right? It's a big deal whether you're in the toaster or outside the toaster. Real big deal. In the toaster, outside, in the natural log function, or outside. So even though you write it real close and everything, if there's no parentheses, it means outside the toaster. And that's not right. All along it was being plugged into the toaster, so that can't change. It's still inside. So you got to have parentheses. Okay, so that's the first step, right? I made dividing becomes subtraction, and now this power will come to the front. The other part stays the same. Hey, can I make this log base 3 of x minus log base 3 of 5? No, there's no such property. That's not multiplying. That's not distribution. That's plug into the toaster. That's not multiplying. But I see that mistake a lot. It's probably worth me spending 30 seconds more saying that again really clearly. This is not right. We're just stop right here. We're done. Right? Why? Because remember, these are functions. That'd be like saying f of x minus 5 is distribute f of x minus f of 5, which maybe you think that's true. That's not true. It's not necessarily true. So it's a function. It's not multiplying. It's not multiplying. Everybody with me on this? So when you look at, that's why I'm always beating that drum. If you go into calculus, you really want to, well, even now, we really need to think clearly about the difference between multiplying and function. Just because there's parentheses there does not mean multiply. It's a function. All these things are logs and exponentials. When we get to trig, we'll review trig in a month or something. Sine, cosine, tangent. Those are all functions. Plugging into the toaster. So this is plugged in. It's not multiplying. We can't distribute. You might think, yeah, but isn't that what the property says? No, careful. What does the property say? It says if you have a log, any base, and they're timesed, right? Harder job, 1 log. Harder job. I always get that backwards. Harder job for 1 person is the easier for 2. That's not distribution, right? That was times becoming adding. That's a special log quality, not distribution. All right. We all good with that? There's no such rule that says subtraction becomes subtraction. No. Right? All right. I think you're like, we got it, Mr. Hand, we got it. All right. So, you want to try that one? There's no base. What's the base really? 10. But you don't have to write it. Don't write it. Just write normal log. We don't do anything with the base on these properties anyway. But just break it into several logs. So notice you have 2 logs multiplied on the top right. Two functions, x and x plus 4. So those will be added. And the one on the bottom divided will be subtracted, won't it? Add the first 2, subtract the third one, and then bring the power to the front. Good so far? Because the x and the x plus 4 are multiplied on the top. The 5 will come down then. You can do it all in one step if you want. And there's our answer. We can't like distribute or anything like that, right? Because it's no such rule. It's a function, not multiplication. So there we go. Is that good? Oh, I got them, and yet there's a bunch of hard ones at the end. So I'm going to do them fast. Probably is what I'm going to do. And they'll be on, what's its name, YouTube. So that half, just jump it to the front right away, right? Powers to the front. That numerator can factor, I'm sure. It's x minus 2, x plus 1. So I wanted to show you that. I thought you might not realize that. They have brackets and parentheses are all the same thing. It's interchangeable, whatever. It's just stylistically different. The meaning is the same. Brackets are the same as parentheses, no difference. Okay, everybody good so far? I just factored that numerator. And then now the half is in the front of the entire log, isn't it? So that means when I break this one log now into 3, the top 2 added, the bottom subtracted. When I break this one log into 3, that half is going to be in front of all 3. Because it's in front of the main log right now. And that main log is going to become 3 logs, so the half's going to go to everybody. So it'll become a half ln of x minus 2 plus a half ln of x plus 1 minus a half ln of x plus 7 to the 5th. Good there. See how that half went to everybody because he was in front of the main log, which became 3. And now, last step, that 5 right here, where's he going to go? Whoops, right there to the top. Kind of get scribbly. Change it. So that's 5 over 200. The 5 just goes to the top, right? Because a half times 5 is 5 over 1, 5 halves. So there we go. We good? All right, I'm going to keep moving. I'm going to run out of time. I can feel it in my bones. All right, so I'm going to break it into 3. So, the reason they're saying x greater than 5 is they don't want that denominator to be 0. You don't got to do anything with it. They ignore it completely. They're just saying it so the denominator doesn't do something weird. Anyway, don't worry about it. Pretend they never said it. Who cares? So, ln 3x plus ln square root of 1 plus 8x minus ln x minus 5 to the 10. So far, so good. Just breaking it into 3. Like that. Okay. Now, you know the trick here. What does that root always do? It's a half power, and then you bring that half to the front, don't you? And that 10 is also coming down. So we get ln of 3x plus a half ln 1 plus 8x minus 10 ln x minus 5. We're done. So roots are half powers, they come to the front. Now, actually, guys, I wonder if they're going to be picky about the 3 and the x. They might be, because that technically is 2 things multiplied, huh? So maybe they want you to make it ln 3 plus ln x. Is that what they want?
It's on the homework.
Oh,
I did that.
so there you go. Yeah. So I guess they want that. Is that good there? All right, I'll keep. So 7 log 5u plus 8 log 5v. So now they say make it a single log. So now we're going to run the now we're going to do all the properties backwards. We're about halfway through the section. Now we're going to start running the properties backwards. We're going to go, those properties I gave you, which said, number 1 said log base b of x times y is log base b of x plus log base by. Now they're starting over here, and they want me to go back this way. Makes sense? You got 2 logs added. Now make that into 1 log. Crunch them together. Run the property backwards. How do you do that? Well, first off, this 7 needs to go up here to the power zone, and this 8 needs to go up here to the power zone, running that property backwards, So it's not in the front anymore, not in the front. And then adding an easy job for 2 people, easy job for 1 log, for 2 logs, I'm sorry, is harder job, u to the 7th times v to the 8th, multiplying, harder job for 1 log. Remember how it always works. Easier operation for 2 logs, adding, super easy, times a little harder for 1 person. Harder job for 1 person, right? Many hands make the job lighter kind of thing. Right? And the bases match. The bases have to match. They will match. You can't do these properties unless the bases are the same. If the bases are different, nothing you can do. No properties work if the bases are different. They won't give you that. Bases will be the same. Good? Log 3 root x minus log 3x to the 6th. Yeah, so subtraction, go ahead and put them together. So they're saying single log. So put them together, run the properties backwards. Subtraction, easy job for 2 logs, will become what? Harder job for 1 log. So it'll become dividing. So far so good. Subtraction becomes dividing. Now though we have to simplify. Well, do we? I don't know. Maybe they'll just take it like that. I'm going to try it. We can't leave this like this. This needs to be simplified. How so? Okay. What is that root x? 1/2. Good so far? A root is a half power, right? They're going to use that a lot. You just want to know that cold. A root is a half power on that. Root's a half power. So now, remember you can subtract powers. Remember that rule from algebra? So, right, if you have like x to the 3rd over x to the 7th, that's 1 over x to the 4th, you subtract them. Wherever the bigger one is, that's where the answer ends up. Bigger one's on the bottom, answer on the bottom. Bigger on the top, answer's on the top. Remember that kind of thing? So 6 minus 1/2. So what is that? Well, 5.5 with a 1, right? You see the 1 on the top, like up here. Come on, let me circle. There we go. Good. Everybody see that? So far, now we can't leave 5.5. Let's change it. Can't leave a mixed number. So it's 1 over x. How do you change 5.5? You multiply. Remember times and add the top. 5 times 2 is 10. Add 1, 11/2. Remember that? Everybody good with that? See what happened here? I just went 5 times 2 is 10, add 1, 11/2. Remember how to change mixed numbers to improper? That good? Are we okay with that? Let's see if it'll take that. See it right here?
No.
Express powers as factors. Factors means things multiplied. So it says, so this is all right. Everything I did here is right. I just didn't finish. So in other words, here, let me show you the last tip. I didn't read the fine print. So they don't want powers. They're saying don't leave any powers. So take this up to here. This is a power, right? So what would be the easiest way? Yeah. So this is a power.
Take off the 1.
Yeah, so this is log base 3 of x to the minus 11/2. You okay with that? Right, 11/2 on the bottom. Negative powers mean bottom. And then you just run that to the front. So negative 11/2 in the front, log base 3 of x. That's easier to type in anyway. There we go. That was painful. See, all that little algebra is a pain.
You should make this homework due on Thursday.
I might have no choice. We'll see. All right, we good with that? Questions on that? Okay. Okay, write it as a single log. So take those two logs and put them together. You can factor that x squared minus 25, right? Put them together first. First, just put them together. What do you do with that 4 power? It's going to go right up there, isn't he? So run that 4 power, I'm saying it, run that 4 in the front up to the power. It'll become a 4 power. And then 2 logs subtracted, 1 log divided, right? Make it 1 log divided. And then factor that x squared minus 25. And you'll be there, basically. So log base 4 of x squared minus 25 over x plus 5 to the 4. Is that okay if I take that big jump like that? Subtraction becomes dividing. The 4 goes to the power zone. Now, what more can we do? This is x plus 5, x minus 5. Good. Like that. And then, are we good? This leaves 3 of them. So it's log base 4 of x minus 5 over x plus 5 cubed. And I can leave that power. How do I know? They never said make powers into factors. Thank you. I'll just leave it. There we go. I'm not typing it in. I'm pretty confident that's right. So, some of you are ahead of me, right? So is that right?
Can you put that in?
Let me know if... Okay, thanks. We got verification.
It's like 1%.
No, I trust in Luis, right? I trust him. All right.
That's like, no. Just do it right now.
All right. So, yeah. So they want us to single log, crunch them all together in a single log. So ln. So things added or multiplied, right? So I'll take x minus 1 times x plus 1 over x. So far, so good. This adding becomes multiplying. But then what about the third one? Well, it's subtraction, which means divide, which means what? Which means you put that x squared minus 1 in the denominator. You put a 1 on the top if you want or whatever. All inside one natural log. So far, so good. See how that dividing, when we say subtraction becomes dividing, what does dividing really mean? Denominator. That's what dividing is. So you see that x squared minus 1 just goes to the denominator. You see that? That's what dividing is. Upside down multiplying. Denominator multiplying. Isn't it? Good so far? Now, we need to factor and cancel. This part will factor. X plus 1, x minus 1. Like that. And then cancel x, cancel x. Cancel x plus 1, cancel x plus 1. So what do we got? ln of 1 over x minus 1 squared. So far, so good. Am I racing ahead of you? We can't stop there, though. Read the fine print on the contract.
Express power.
Meaning, don't leave any powers. So I got to bring powers to the front. Powers to the front. So that's ln of x minus 1 to the minus 2, because it's on the bottom, right? You good with all? It's all that little stuff that's hard. It's power rules and denominators, negative power. All those rules that you got to practice and get straight. I'm glad to help you. Come to office hours or see Roberto, help you with all those. But that, and then bring that to the front. Negative 2 ln x minus 1. There's our answer. That good? You see all those steps? So again, from the beginning, the adding became times, the subtraction became upside down times. That's what dividing is. Factored and canceled, got to here, said, oh, that's negative 2, bring it to the front. Questions?
Keep that up there for
All right. Start putting them together. Where's that 8 going to go? Power. What's the square root? Half power. Then there's also an 8, half of 8.
I'll just wait for you to do it.
Fourth power up there, right? It's going to become a fourth power up there. See that? Because the root's a half power. And the 8 goes to the power. So half of 8, both in the power. The half and the 8 both end up in the power zone. Half of 8, 4. Right? You see all that? So that... Oops. So the 8x, that's a half power. That's what a root means. And then times the 8. Because that came up there also, huh? Minus. I'll just do that step first. How about I just do that? Oh, log base 3 of 3. Have you a calculator? You don't need a calculator. Remember how when it's all numbers and there's no x at all, then you just let the high go high and the low go low. I don't need a calculator to tell me what that is. That's 1, right? Okay, we can get overly dependent on the calculator. You don't want to type that into your calculator.
You gotta be super.
I was working with my daughter the other day. I'm always giving her a hard time. She's in Calc 3, and she was at the end of a Calc 3 problem, and she had 3 minus 2 or something like that, and she typed it into her calculator. I was like, honey, really? Really? You're in Calc 3 and you're going to go 3 minus 2 in your calculator? So she's like, oh, she smiled. Yeah, that's right. Didn't see that one, Dad. All right, so this is a 1, right? Okay, so log base 3, and this is 8x, half times 8? Half of 8? 4. Right? That good? Okay. Now, minus, here's the real trick. What are you going to do with that minus sign there? Minus means divide, right? But what is divide? Upside down multiply. In other words, multiply by x over 3. See what I just did? Or if it bugs you putting it over there, just put it right here. Really, you can put it anywhere. But if that seems strange to you, do it like that. Does that make sense? Dividing is upside down multiplying, right? Dividing is upside down multiplying. Right, you know that. Think about, remember from your earlier days, 2 over 1 divided by 3/7. Remember how we would flip the 1 on the right and make it upside down multiplying, right?
Sorry.
Dividing is upside down multiplying on that. Okay, so keep going, and then what about, and then we got this plus 1 off to the right. Yeah. Okay, so then what? This is a weird problem. Oh, you know what? I shouldn't have done that one thing.
Oh, Mr. Hamel, we're out of time. We're out of time. Mr.
No, we got 2 good minutes.
We got 30 seconds.
No way. We could. I mean, it's true. It's 1, but I'm not following their instructions. Single log. They want 1 log. They don't want like a separate 1. So what? We'll just say, well, look, it's just adding. Whoops, it's adding. So that's times 3. You with me? Right? That's the rule, right? Adding between 2 logs is times all within 1 log. So then these cancel, don't they? So we have log base 3 of 8x minus 1 to the 4th times x. And we don't have to do anything with that power. They never said powers to the front. So we'll just leave it like that. You see why they're not saying powers to the front? Because that power's not on everybody. You couldn't put him to the front. He's not the x's power. So that's why they don't say that. They know it's going to come out that way.
Why did you make the 4?
Because if I was to put a 4 in the front of any log of blah, 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 that means he was the power previously of everybody. And he never was. If he was here, if that 4 was outside here, you could totally put him to the front. Because that means he's everybody's power, so he becomes the multiplier for everybody. But if he's only the power for part of the deal, but not the whole deal, you can't put him in the front.
Does this still need a mark?
Oh, I guess we didn't finish.
So
Oh,
Thursday?
right.